Today what we're going to talk about is adding and subtracting radical expressions. In problem number 1, we're going to review in which scenarios we're allowed to add or subtract radical expressions. Now in general, there is one rule that you always need to follow in order to add or subtract radical expressions. And this rule is that all radicals need to be exactly the same in order to be added. So if you have a group of radicals and you're trying to add them, both the index and the radicand have to be the same. So let's look at example A. In example A, we have 3 square root of 5x minus 2 square root of 5x. The first question that we need to ask ourselves is, the radicals that we have, just the radicals, are they exactly the same? And the criteria for that is to have the same index and the same radicand. So if we look at inside the radical, both of them have a 5x, and on the corner over here, both of them have the same index. So this problem right here is okay to add. When adding or subtracting radical expressions, we just need to add or subtract the constants in front of it. We never actually change the radicand, the number inside the radical. So this is actually going to become 3, this is the 3 where we get the 3 from, minus 2 square root of 5x. So 3 minus 2 is equal to 1. We still have the 5x, or the square root of 5x. We haven't changed that. And once we finish that, it's just a matter of simplifying. So the answer is 5x. Now let's look at example B. In example B, we're going to ask ourselves the same questions as we did before. Do we have the same radicals? In the first term, we have a radical of 7, or the square root of 7. But on the second, we have a radical of 5. Since these two radicals are different, we cannot add this. So this expression cannot be simplified. Or added together. Because the radicands, the numbers inside, are different. Now for the last one, what we need to do is the same thing as before. We have to ask ourselves if we can add these two radicals together by looking at the radicals themselves. Now if you look at inside the radical, the radicand, you have 7xy, okay, which means that at least in the inside they're the same. But look at the index. One has an index of 3 and the other one has an index of 4. So like before, this cannot be added because the radicals are different. Now take a moment right now to try the practice problems A, B, and C. Be careful to look at whether the index is the same and the radicands in the cell the same. If they're both the same, all you need to do is add the coefficients. It's different from multiplication. In multiplication, you multiply the outsides and the inside expressions and combine them into a single radical. And it almost always works, with the exception of having a different index. But in addition and subtraction, you're only allowed to change the constant in front of the radical, the coefficient. Now the rule that you can only add when you have different same radicals still applies, but sometimes you have to remember that before you can arrive to that conclusion, you need to make sure that all the radicals are simplified. Now let's look at problem number 3. As it is presented to us, the problem square root of 12 plus the square root of 75 minus the square root of 3 cannot be added. Okay? And it's easy to draw the conclusion that this cannot be done. But, okay, square root of 12 and the square root of 75 can be simplified. So your first step should always be, before you can arrive to a conclusion, simplify all the radicals as much as you can. So that's going to be the step number 1. So in order to simplify a radical, we have to break apart the radicand into its prime factors. In order to do so, we would use the factor 3. Okay? If you want to see an example of how to do this, look at an earlier video. I'm only going to do 12 to show you where I get the numbers from, and then I'm just going to quickly do 75 without showing you the factor 3. So very quickly, the factor 3 is done by splitting apart the number into prime factors, like 2 and 6, and then splitting the 6 into 2 and 3. Once you have all the branches of that factor tree completely made, you need to write the list of prime factors. Since we have two factors, that means that 2 is going to get a power of 2. 1, 3 means that we have a power of 1 on the 3. It also means that instead of writing the square root of 12, I would rather write the square root of 2 squared times the square root of 3. I already also split it apart into individual factors to make it easier on myself to simplify. For 75, after we do the factor 3 and everything, you're going to get the square root of 5 squared being 25, and the square root of 3. Okay? So, we have all that. And of course, 3, in this case, cannot be factored. 3 is already a prime factor, so we leave it alone. Once we do that, we simplify the radicals that we know are going to simplify. So for the first term, the square is going to cancel out the square root. So we're only left with a 2 and a square root of 3. The square root of 3 is the same because we're going to simplify. Same thing with the square root of same thing with the square root of 5 squared. The next step is to add or subtract, or ask yourself, better yet, ask yourself if we can add these two together. The criteria is that we have to have exactly the same radical for all 3 terms. The first term has a square root of 3. Second term has a square root of 3. And the third term has a square root of 3. Since we know that all 3 terms have the same square root, we're going to add them together. That means that for our purposes, we're going to add the constants, or the coefficients, better yet, coefficients, of each term. So, we have a positive 2, a positive 5, and a negative 1. This actually has a negative 1 here in the front. We're going to get 2 plus 5 minus 1. And then the radical of 3 is still the same for all of them. Simplify that. 2 plus 5 is 7. Minus 1 is 6. So our answer is 6 square root of 3. Now, if you had variables, and maybe one of those variables wasn't completely simplified, as your last step, you would simplify. Again, if you needed to. But in this case, we don't. But I'm just going to add the step anyhow, just to show you in case. And we're done. Now for problem number 4, we're going to multiply binomial radical expressions. Now it might not look like, but in this problem you actually have to do 2 operations. Multiplication of radical expressions and addition of radical expressions. And we have to use FOIL, which is something we learned earlier in the year. So we're going to go ahead and do example A and see what happens, what we need to add, and what we need to multiply. Anytime that we're multiplying binomial expressions, you have to remember that you have to FOIL. Multiply the first terms together, then the outer terms, the inner terms, and the last. In blue, I'm going to multiply the first and outer terms. And then you're going to see arrows showing you what I'm multiplying together. So for the first one, I have 4 times 5, which is going to give me 20. Then I'm going to multiply the 4 times 4 square root of 2. Now remember, the rules of multiplication of radicals say that if it's outside the radical, you can only multiply it to things outside the radical. In this case, that simply means we only multiply the 4 and the 4 together. And that should get you 16 square root of 2. What we're going to do now is multiply the inside and the last terms. That means that we're multiplying the 2 square root of 2 times the 5 and the 2 square root of 2 times the 4 square root of 2. So let's first start with the 2 square root of 2 times 5. Once again, the same rule still applies. The numbers on the outside are multiplied together, and the numbers on the inside are multiplied together. Since the 5 doesn't have a radical, we simply multiply it to the coefficient of 2. So that's going to give us 10 square root of 2. And then we're going to do the last 2 terms, where we multiply 2 times 4, which gives you 8, and we multiply the square root of 2 times the square root of 2, which is going to give you the square root of 4. Be careful with the last part. Okay, whenever you multiply radicals, if you indeed have a radical, you're going to multiply the inside of radicals and simplify later on. Our next step is to simplify. For us, that means that if you have a radical that you can simplify, you're going to simplify it. And if you could add or subtract something, you're going to add and subtract something. So let's start from the back with 8 square root of 4. Now 8 we have nothing to do with because it's already in its simplest form. But if we look at square root of 4, everybody should know what the square root of 4 is, which is equal to 2. So that means that what used to be square root of 4 became square root of, it became 2. And we're going to multiply it together to a coefficient of 8, which gives you 16. And of course, remember, we still have a plus on the front. Then, let's see if we can add something together. Now, in the middle 2 terms, you notice that you have the square root of 2 and the square root of 2, which means those middle 2 terms can be added together. And all we need to do is add the coefficient, which is 16 plus 10. And of course, we never actually change the square root of 2. That's the reason why they need to be the same. Simplify that. You're going to get 26 square root of 2 for the middle. And the last part, just remember that there's nothing to do with 20. So we're going to bring it down. Now, of course, we still need to simplify because guess what? 20 and 16 are like terms. So we're going to add them together as well. So 20 plus 16 gives you 36. And we still have the 26 square root of 2. And that's our final answer. Example B follows the same principle. Since we have binomials, things that have two terms, we have to multiply them together. And I made a little mistake. I wrote the wrong expression. So let's erase it. So we're going to multiply together 3 minus the square root of 7 and 5 plus the square root of 7. So let me rewrite the expression, okay, and begin to FOIL. We're now going to FOIL the negative square root of 7. Now be very careful, because notice that you will have a negative in front of the radical. So that means you're multiplying a positive times a negative number, which is going to give you a negative number. 5 square root of 7, and then negative square root of 7 times the square root of 7 gives you negative, because it's still negative times a positive, square root of 49. Our next step is to simplify where we can. Let's start from the back once again and see what we can do from the last number. In the last number, we have the square root of 49. So the square root of 49, you should know, is equal to 7. Then on the middle, we notice that both the 3 square root of 7 and the negative 5 square root of 7 both have a square root of 7. So we're going to get 3 minus 5 square root of 7, which becomes negative 2, because the 5 is the bigger of the two numbers, and it's also the negative number, square root of 7. And we just bring down the 15 in order to simplify. The last thing is to make sure that you simplify those really easy constants like 15 and 7. Now 15 minus 7 is equal to 8. And we still have negative 2 square root of 7 as our final answer. And we're done. Make sure that for practice problems, you do the problems under problem number 4. And if you haven't done so already, do the problems under problem number 3. Alright guys, remember to do these practice problems and have them done by Friday, so you can turn them in along with your guided notes. And that's it for this lesson. Let's continue to the part B of this lesson. Now this is the second part of adding and subtracting radical expressions. This part is special because we're learning about the conjugates. Now the conjugates are very important because they're an incredibly powerful tool to get rid of and therefore simplify radical expressions. So let's look at problem number 5. On problem number 5, like problems 3 and 4, we're going to FOIL again. But I want you guys to pay close attention to what happens. Look at what we begin with and look at what we end up with after we simplify. We're going to FOIL like before. So 5 times 5, 25. 5 times the square root of 7, 5 square root of 7. Negative square root of 7 times 5 gives you negative 5 square root of 7. And the negative square root of 7 times the positive square root of 7 gives you negative square root of 49. So take a second to copy that down. If you need to, pause the video. Your next step is to simplify as much as you can. Okay, let's start from the back as before. Notice that the square root of 49 is going to become 7. In the middle, if you look at it closely, both of them have a square root of 7. So we have 5 minus 5 on the front, square root of 7, and 25 at the end. once we simplify this, notice what happens in the middle. 5 minus 5 is equal to 0, which means you end up multiplying by 0, which makes the middle terms cancel each other out along with the radical. Doesn't matter, anytime you multiply by 0, it could be apples, pie, whatever, it always destroys it. It cancels it out. Once we're done with that, all we need to do is add 25 or subtract 7 from 25. That's the correct way of saying it anyhow. And you're going to get 18. Now take a second to appreciate this problem. We began with 5 minus square root of 7, multiplied it to 5 plus square root of 7, but our answer does not have a radical. And that's the special properties that conjugates have. They canceled out radicals. So if we're able to find them and use them, they're going to make our life a whole lot easier. So let's go to the next problem. Our task for problem 5.5 is to find the conjugate. And I'm going to tell you in 2 easy steps how to find it. Now always when you're trying to find the conjugate, make sure that you have the correct conjugate by multiplying it together to the original. And that's going to be our third step. So let us begin. Alright, the original problem says find the conjugate of 1 minus 3 square root of 2. Okay, that's our original problem. For step number 1, what we're going to do is use the same numbers without any signs. So that means that for our purposes, we're going to use 1 and 3 square root of 2. So notice that I neglected to write the sign, negative sign, okay? Because that's going to be what we discussed in step number 2. Now in step number 2, you're going to change the sign in between the numbers. So if your sign was negative, we began with a negative, our new sign is going to be positive. So we started with a negative, it's now going to be a positive. Okay? And that pretty much is how we find the conjugate. This right here is the conjugate. Okay? Of 1 minus 3 square root of 2. Now what we're going to do in step number 3 is double check to see that it works. And in order to double check that it works, we're going to multiply them together. And of course, since we're multiplying binomials, we have to FOIL. So, like I said before, you're going to multiply the original to the conjugate to see that it works. And we have to FOIL. Or I'm going to do this very quickly because I'm expecting you guys to be able to FOIL binomials by now. Now be careful of the last part because you're multiplying the square root of 2 times the square root of 2, which gives you the square root of 4. And we're multiplying the outside coefficients, which is 3 times 3. So let's start simplifying. Square root of 4 becomes 2. The middle terms cancel each other out. And you still have 1 on the front. At the end result, you have 1 minus 18, which is negative 17. So it works because we have no radicals. And that's it. Pretty much, just have to use the same numbers, but change the sign. Once you multiply them together, the end result, you have no radicals. Now problem number 6 addresses the reason why we need to know the conjugate. We need to know the conjugate because it allows us to simplify fractions with radical expressions that have a binomial expression with radicals in the denominator. So when the denominator has two terms, they could be radicals, they could be variables, or they can be regular numbers, okay? But we have two terms. We need to know how to find the conjugate and use it to our advantage. So let's start looking at problem 6. So we need to know the conjugate because we have two terms. If we look at problem number 6, notice that on the denominator we have the square root of 5 minus the square root of 2. Clearly two terms, and they're not being multiplied together, so it's not as simple as multiplying by a single radical. It has to be done with two radicals, two different radicals in this case. Our first step is to find the conjugate of the denominator. Now let's remember that the original denominator was square root of 5 and square root of negative 2. Its conjugate is going to be the same numbers but a different sign. So instead of minus, we're going to have a plus. And that's all we need to do for this step. For step number 2, we're going to multiply the numerator and the denominator by the conjugate. So to multiply the top and the bottom by the conjugate. Just remember that we originally have 3 square root of 2 on the numerator and square root of 5 minus the square root of 2 on the denominator. And we're going to multiply by the conjugate. We're going to multiply the top and the bottom by the conjugate. So that means that on the top, we're going to multiply it by the square root of 5 plus the square root of 2. And on the bottom, we're going to multiply it also by the square root of 5, square root of 2. And we just have to distribute. On the top, when we multiply the 3 square root of 2 times the 5, and the 3 to the square root of 2 times the square root of 2, we're going to get 3 square root of 10 and 3 square root of 4. On the bottom, we're going to get the square root of 25 because we're multiplying the square root of 5 times the square root of 5. Then we're going to get plus the square root of 10 by multiplying the square root of 5, positive, and the square root of 2, positive as well. Then the negative square root of 2 to the square root of 5 gives you negative square root of 10. And the negative square root of 2 times the positive square root of 2 gives you the negative square root of 4. Our next and final step is to simplify. Add what needs to be added and simplify any radicals that we need to simplify. So we look at the top here. We notice that we cannot simplify the square root of 10, but we can simplify the square root of 4, and that becomes a 2. Then our issue is that we're going to have 3 times 2, which is simply 6. So here on the bottom, we have a plus 6. 3 square root of 10 is still the same. On the denominator, square root of 5 becomes a 5. Square root of 4 becomes a 2. We have a negative in the front. Those two eventually we're going to subtract because they're like terms. On the middle, positive square root of 10 and negative square root of 10 cancel each other out, so they become 0. On the bottom, we have 5 plus 0 minus 2, which gives you 3. Now, since we got into this point, notice that we still have a number in the denominator, but the two terms on the numerator are both technically divisible by 3, because the coefficient on 3 square root of 10 is 3, divisible by 3, and 6 is also divisible by 3. So in a way, we're going to distribute, but we're going to divide. So 3 divided by 3 gives you 1, which means the first term and the denominator that goes with it simplifies into simply the square root of 10. On the second part, we notice that 6 divided by 3 is equal to 2. That means that the combination of those two numbers, once we distribute, is going to simply be the square root of 2. And we're done. Now, as a last reminder, guys, just remember to do all the practice problems. We did sections A and B in this video because I thought they were easy enough to put together in a single video. But just remember that this is due on Friday when you turn in your notes, okay? If you have any questions, just bring them to me before or after school, and I'll be more than happy to answer. Or just post them on the Moto. And that's it. See you later.